Other people feel that way too? Yeah. So our next pair of speakers are going to talk about an application that they built during an event in Seattle called Hack the Commute. Hack the Commute was an event, a hackathon in Seattle to help foster greater mobility in the city. So please welcome to the stage Nick Bolten and Yun Hao.
Hello, everyone. So I'm Nick Bolten, and this is Yun Hao. Looks like they're pulling up the presentation. Cool. So we're here with the AccessMap project. So we're going to talk about specifically using open data to create reliable sidewalk trip planning for people with limited mobility. So before we start, I just want to tell you a quick story. So there's a local blogger in Seattle named Randy who's a wheelchair user. And one of the stories that he tells is about how one day he was traveling in Seattle trying to get to his destination, and he ran into some unexpected construction. Not knowing where to go because there wasn't a detour sign, he waited there until a construction worker came up and showed him another way that he could go. It turned out that the detour that he took had a temporary ramp built out of soft asphalt, and in the process, he sank into that asphalt and got stuck. So for him that day, that outing was a complete no-go. Sidewalk accessibility is a huge issue that affects a lot of people. 30.6 million people aged 15 and older had difficulty walking, climbing stairs, or otherwise use a wheelchair, cane, crutches, or walker. And 23.9 million people had difficulty walking a quarter of a mile. Our project started as part of Hack the Commute, as was just mentioned. This was a collaboration between Socrata and the City of Seattle, focused on solving transportation issues for the City of Seattle by bringing together community members, experts, and local developers. And we gravitated towards the table that was focused on accessible issues. In particular, we wanted to talk about accessibility and mapping. So what is currently available for people with limited mobility if they want to plan out their commute? Usually you can see a static map like this one. This is for the University of Washington. This shows all the accessible buildings as well as potential paths you could take. But as you can see, it's because it has to contain so much information, it's very, very busy. And it's not necessarily up to date because it has to be this static PDF. You're not going to get up-to-date information like you might be able to get otherwise. So our design question was, how can we help people with limited mobility find safe routes tailored to their needs? Our solution, which won the hackathon, was AccessMapSeattle.com. This is a web application that shows a web map that displays open data in an easy-to-consume format. So for this, we show every sidewalk in the city of Seattle, color-coded with elevation change information, so how steep it is. For this, we also show curb ramps, construction that might block the sidewalk, and bus stops. So you can self-plan a commute if you have this information. Over the summer, we really wanted to add functionality to this map. In particular, we wanted to get routing working to give a much simpler and better interface for planning your commute. Like when you use Google Maps, you usually don't want to plan out your own route step by step. You want to say, I want to start here and go here, and it figures out the best route for you. So for this, we were sponsored by the eScience Institute Data Science for Social Good project over the summer. They supplied us with 4 data science fellows as well as data scientists to help work out this problem. And here with us, we have Yun Hao, who is one of the data science fellows, and she's going to tell you about our project.
As Nick said, we want to provide routing service. So the question is, what is routing? I think there are 2 requirements. First, we need a map, a sidewalk map that is correct and complete, which means if you can go from position A to position B in the real world, in our sidewalk map, you need to go, there has to be a path between location A and location B. The second requirement is to pick the best route. We need to add some information to the sidewalks. Those information might include curb ramps, crossings, constructions and elevations. But we encounter the biggest enemy of open data, which is errors. We classify the error into two categories. The first kind of error we see is the error we expect to see in every cities. So there are overlapping breaks on the sidewalk. We call it noisy end. And you can also see from this map that there's no way to go across the street on sidewalks. We need to create crossings. The second kind of error is city-specific error. For Seattle, there is always a mysterious gap in the intersections that looks like letter T. We also want to clean them. So our goal is pretty clear. We want to fix those errors automatically and build a compiled software package that can produce routable sidewalk map. We want it to be usable for all cities. We also want to keep it open and free source. We create a 5-step workflow. There are 3 major steps on the left. First, we clean those errors. Second, we add crossings. Third, we add annotations. The first step is to clean city-specific errors. This step might be different in different cities. We want to do this first because after this step, we can use the same package for all cities. For Seattle, there is always a gap in the intersection look like letter T, so we use street information to find all those T intersections. We find gaps in those intersections, and we fix the error. Now we are ready to clean those noisy ends. We use street information again and divide the intersection area into 4 regions in this example, and we connect all those sidewalks that belong to the same area. But there are some areas that are far from the intersections. So by using divide and conquer strategy, we use street to create blocks. And we fix errors inside those blocks. So after those 3 steps, 90% of the errors are cleaned. There are no noisy end and city-specific errors in these maps. So now we are ready to add extra information to our maps. First, we add crossings. We go to intersection area again, and we find all those sidewalk corners. We create crossings by connecting them if there is a street go between them. And we also add those information that might affect the mobility on the sidewalks. For example, in this figure, we have 1 construction, 2 curb ramps, and 2 crosswalks. To summarize, first we clean the errors to make the map correct. Second, we add crossings to make map connected. Third, we add those annotations to make the map routable. Finally, we are ready for routing.
Cool. So the project was a success. So over the summer, we got that data layer built, and there's a super alpha version that's not quite live yet that does do routing for you. You can see, as an example here, all of the sidewalks color-coded by elevation change. The red means very, very steep. And if we start on the left, point A, to the point on the right, point B, which is Seattle City Hall, the shortest path would go through those reds and would be impassable for someone in, for example, a manual wheelchair. But with our routing algorithm, you can account for that and route around, go a couple blocks up, and just take much, much less steep routes. So why is this important? Someone like Randy, for example, would be given a route that does not include construction in the way. So you could plan in advance to avoid things that might delay or otherwise ruin your trip. In addition, we think that this could have applications outside of helping people with limited mobility. And so we think this is a good project going forward for building data layers and analytics. So what are our next steps? We'd like to finalize that routing interface and get it online. We'd like to generate routing profiles for users with different abilities or preferences. So a manual wheelchair versus a powered wheelchair user will have different preferences on how they can route. We're developing mobile applications right now, and we want to provide accessibility analytics for the city. It's available online. You can try it right now at accessmapseattle.com. We'd like to give a special thanks to the UW eScience Institute Data Science for Social Good project, the City of Seattle, our mentor, Annette Caspi, who's the director for the Taskar Center for Accessible Technology at UW Computer Science and Engineering. And I'd like to give thanks also to the other AccessMap members, Ali DeFord and Veronica Sapiva.